Okay, continuing on with section 1.15, which is our horizontal asymptotes, we are going to start with example 11 where the last video concluded. So example 11, finding horizontal asymptotes. Determine the equation of any horizontal asymptote, if any, of the graph of the given function below. First thing I notice is I have a power of 1 for the degree in the numerator, and I have the square root of x squared in the denominator. So, which would turn out to be absolute value of x. So I am going to say that they're basically equal, and I just need to watch my positives and negatives. So what I'm thinking is the limit as x heads to infinity of 8x minus 1 over square root 2x squared plus 1 would turn out to be 8x over square root of 2. Square root of 2. Now, would it be positive? If I'm headed to positive infinity, this would be a positive, and this term would be positive. So positive divided by positive is definitely going to be positive. So I can get 8 over square root 2. You can rationalize that if you love rationalizing things, go for it. In the AP world, you don't have to rationalize the denominator. All right, the other one, so we definitely have a y equals 4 square root 2 horizontal asymptote. Now let's look at negative infinity. So the limit as x approaches negative infinity of 8, because we want to write complete mathematical statements here, no shortcutting, we get 8, and if I put negative infinity on top, I'm going to have a negative. On the bottom, I'm going to have a positive square root 2. So it looks to me like we get negative 8 over square root 2. Rationalized would be negative 4 square root 2. So I also have left end behavior of negative 4 square root 2 and right end behavior of the positive 4 square root 2. Example 12, determine the equation of the horizontal asymptote. So here is our function. Let's dig a little deeper and look at the limit. As x goes to infinity, let's do positive infinity first. And I'm going to have sine of x over x. And you're kind of like, well, wait a minute. Sine of x does not settle in on any one number as we head to infinity. However, it is a bounded graph. So for this one, we've got to do a little bit of thinking kind of outside the box. Bounded range is what we want to say. Not a domain, but a bounded range. And that bounded range is going from -1 to 1 are the values that x can take on. So if I think about my numerator being some value between +1 and -1, and the denominator where our x is, that should say denom, totally wrote that wrong, denominator being infinity, what do you think this goes towards? Well, it would go towards 0. The bottom grows so much faster, and the top is contained, so our horizontal asymptote is going to be 0. And then you're probably wondering, well, what happens the limit as x goes to negative infinity of sine x over x? Well, once again, our top is bounded by a very small number, right? Might be positive, might be negative. And then I'm coming in with negative infinity. Let's do implies. So this, I can think of the numerator as being something between -1 and 1, bottom being negative. It's still going to tend to 0, but from the underside, from the negative side, the left side of 0. But it's still 0. So do we have a horizontal asymptote? We're sure we do. Yeah, we got a horizontal asymptote at y equals 0. Both left and right behavior are going to tend towards 0. This is from the 2012 AP, multiple choice question, no calculator. The line y equals 5 is a horizontal asymptote to which graph, to the graph of which of the following functions? Whew, what will it be? Well, this one here, this still is bounded on its range, isn't it? Sine of 5x only affects the period, how quickly it cycles through. So it's still ranging between -1 and 1. The bottom's growing to infinity, negative or positive. This thing's going to 0. So y equals 5 is not the horizontal asymptote. Well, this is a linear function, right? Linear function, it looks like this. That's tending to infinity. There's no horizontal asymptote, so it's not B. If x were 5, I have a domain issue, don't I? It's the domain of all reals where x cannot be 5. That's a vertical asymptote of x equals 5. So C is not the answer. And let's see. Similar degrees, but a negative x. The coefficients are what I'm zooming in on. The coefficients would say 5 divided by -1, which would give me -5. I have a horizontal asymptote of y equals -5. That is not it. Okay, well, let's hope this last one maps out for us. Highest degree in the top, highest degree in the bottom, and that would be 20 divided by 4 gives us 5. That says 5 there. E is the answer. 2008, what are all the horizontal asymptotes of this? I'm going to focus in on our very largest degrees, which is 2 to the x over -2 to the x. Now, this one we haven't discussed before. And with that x being in the exponent position, that makes it a little trickier. So the limit as x goes to positive infinity of 5 plus 2 to the x over 1 minus 2 to the x. It would be like 2 to infinity over -2 to infinity. They are essentially the same item. This is going to have a limit of -1. Let's say that this implies, since we're working with a concept of infinity. All right, in comparison, let's switch over and look at the limit as x goes to -infinity. This is the one you've got to watch out for. So like the first, I'm really kind of zoomed into, did I write -infinity? Okay, I did. That's fine. We can do that. You know what? I shouldn't there. Let's not do it yet. Because I want to say this implies then that I have 5 and I can't ignore 5 because I'm putting -infinity as the exponent. And we know what that means. It will drag the 2 to the negative power to be a denominator. Same with the bottom. I'm going to have 1 minus 1 over 2 to infinity. That's interesting because now this little portion goes to 0 and this little fraction also goes to 0 because now I got 1 divided by large. And my final answer on this would be 5. So we have y equals 5 and a y equals -1 for our, looks like we have E on that one. Okay? And the last one, it says it is similar AP. We do see these over and over in the AP. The last one has an answer of D. I'm going to let you work that one out and see if you can figure out why that happens. Slant asymptotes. Slant asymptotes are not likely to ever be tested on the AP test, but you did learn about them in pre-calc. So let's go over them real quickly. Slant asymptote. If I have a rational function, f over x, where f and g have no common factors, so it's not going to reduce down. And I noticed that the degree of the denominator is 1 degree greater than the degree of g of x is 1 or greater, and the degree of f of x exceeds the degree of g of x by exactly 1. It's the numerator is 1 degree higher than the denominator, is what that is saying. Just have to read it carefully. Then the function has an oblique asymptote. Oblique meaning slant. Kind of like an oblique cylinder. Looks like that. It's got a lean to it. The equation for the asymptote always comes in the form of the y equals non-remainder portion of the quotient when the polynomial, when long division is used to divide f of x numerator by g of x denominator. So let's look at an example of an oblique asymptote or slant asymptote. What I notice, let's do a comparison of degrees. So compare degrees. And in this case, I also noticed that if I factored the top, it would be an x plus 2. No, it wouldn't. Doesn't look factorable to me on top. So no cancellation or reducing of this particular rational function. The degree on the top is 1 degree more. No, it's actually 2 degrees more than the bottom. And we will go ahead and do the division. Okay, so we're going to long divide that. And the degree exceeds the degree by exactly 1. I thought that's interesting. Okay, well, let's do the degree. We could have used synthetic on this one, having such a nice divisor. Oh, my goodness. We are different by 1 degree, aren't we? I don't know what I was thinking. So, how do we do long division? Long division. I'm going to work with x going into x squared. How many times? It'll go in x times. Then I go into multiplication. X times x gives me x squared. X times negative 2 gives me negative 2x. I work on subtracting that line from the former line. So x squared minus x squared gives me a 0. And then I have negative 2x minus makes plus. I'm also getting 0 there. And then I get plus 4 as a remainder. So we know that this would be plus 4 over x minus 2. But in our instructions for the definition of oblique, it says the non-remainder portion is used. So I just ignore any remainders and I get the equation y equals x for my slant asymptote. We will have a Delta math assignment on this particular lesson, so good luck.